Assalamu alaikum students. We continue exercise 2.6. In question number 5, we are required to calculate four different things: z bar, z plus z bar, z minus z bar, z dot z bar. Z bar stands for conjugate of complex number. So we are required these four things for each of the following, part 1 till part 4. To find these four things for each of the following parts, let's begin with the part 1, and that part 1 is z is equal to minus iota. As we know that z bar stands for conjugate of the complex number and the complex number is minus iota. In the previous lectures we learned how to find the conjugate of a complex number. It is very simple. If we change the sign of the imaginary number, imaginary part, so ultimately we got its conjugate. So let's begin with the A part, in which we are required to find its conjugate, and now we write iota. In part D we are required to find the sum of the complex number and its conjugate, that is z plus z bar. Already we have both the values. We put the values minus iota plus iota. Like terms having different sign, they become cancelled. So z plus z bar, simply we have what? Z plus z bar is equal to 0. In part C, we are required to find out the difference of these two, z minus z bar, and that is minus iota minus iota. Like terms having same signs, the coefficients are added, minus 1 becomes minus 2 iota. This part is also very simple and we easily calculate it. Part D. In part D, we are required to find out the product. So how we find the product of the complex conjugate? Simple. We put the values minus iota into iota. What we get over here, minus plus minus, iota into iota, added will become iota square. Minus, put the value of iota square, that is minus 1. Already we know that iota square is equal to minus 1. Minus into minus equal to plus 1. So the product of complex conjugate over here is equal to 1. And that's it for the part 1. Let's begin with the part 2, which is z is equal to 2 plus iota. Again, in part A, we are required to find its conjugate, and conjugate is obtained by changing the sign of the imaginary coefficient. So hence we have 2 minus iota. Part A is solved. Part B, in part B we are required to find their sum. So z plus z bar, that will be equal to 2 plus iota plus 2 minus iota. We open the bracket, 2 plus iota plus 2 minus iota. Real parts are added, so 2 plus 2, 4, and imaginary coefficients are alike terms having different signs, they are cancelled. So we have z plus z bar is equal to 4. Part C, in part C we are required to find out the difference. Z minus z bar is equal to 2 plus iota. We put the values, 2 minus iota, 2 plus iota minus 2 plus iota. What we have, 2 and 2, these are like terms having different signs, cancelled. Imaginary coefficients are added as the signs are same. 1 plus 1, 2. It becomes 2 iota. Z minus z bar. In part D, for this second part, we are required to find out the product, z dot z bar. We put the values, z is equal to 2 plus iota, and value of z bar is 2 minus iota. Already learned the method of multiplication in algebra. We know that either we multiply these by simple method or we use formula. We use formula because that becomes really simple. So how? A plus b into a minus b, that is equal to a square minus b square. So we got 2 square minus iota square. 2 square is equal to 4, iota square, we put the value minus 1, 4 plus 1, minus minus plus, so 4 plus 1 becomes 5. So we have z dot z bar, that is equal to 5. That is for part 2. Let's begin with the part 3, which is z is equal to 1 plus iota over 1 minus iota. Again, we have already in the previous questions we discussed how to solve such rational form of complex numbers. It's very simple. We rationalize them first and then after we can solve. So let's begin with this part 3. Z is equal to 1 plus iota over 1 minus iota. Before taking its conjugate, we have to rationalize it, and for this purpose what we do, we multiply and divide by the conjugate of the denominator, 1 plus iota over 1 plus iota. We are familiar with this methodology. Multiplying numerator to the numerator, what we get, 1 into 1 plus iota plus iota is multiplied to 1 plus iota divided by 1 minus iota, 1 plus iota. We apply formula over here, 1 square minus iota square we have. Solving the numerator, we get 1 plus iota 1 is iota plus iota into iota square. In denominator, 1 square is equal to 1 and iota square we put the value minus 1. 1 is carried to the next step in numerator, and like term having same sign, the coefficients are added, so we have 2 iota and we put the value for iota square, that is minus 1, divided by 1 minus plus 1. In the next step, 1 plus 2 iota plus minus 1 divided by 2. 1 minus 1, like term, different sign cancel. 2 iota divided by 2, 2 is cancelled by 2. What we get over here, iota. We got rationalized form of what? Z. As we got the rationalized form of the given complex number, so now we can solve this for part A, in which we are required to find its conjugate, and conjugates are found by changing the sign of the imaginary coefficient, and we have over here iota, so we get what? Minus iota. In part B, we are required to find out the sum, so z plus z bar, that will be equal to, the value of z is iota plus minus iota. Iota minus iota will be equal to 0. Z plus z bar simply obtained. In part C, we are required to find out the difference, z minus z bar, and for this we put the value of z is iota, whereas value of z bar is minus iota. Iota minus plus iota, like terms, the coefficients are added, we got 2 iota. In part D, we are required to find out the product of the complex conjugate, that is z dot z bar. We put the values, and that is iota into minus iota, plus minus iota into iota square. We replace the value of iota square, that is minus 1, minus plus 1, and simply we get z dot z bar is equal to 1. Now we do part 4, in which we have a rational form of a complex number. So rational form of complex number can only be solved by rationalizing it, and we rationalize it by multiplying by the conjugate, which is 2 minus 4 iota, and divided 2 minus 4. Numerator is multiplied to the numerator as 4 multiplied to the 2 minus 4 iota, minus 3 iota is multiplied to minus 4 iota, divided by, applying formula, we got 2 square minus 4 iota square. The formula is a plus b, a minus b is equal to a square minus b square. 4 2s are 8, minus 4 4s are 16 iota, minus 3 2s are minus 6 iota, minus plus 3 4s are 12 iota square. We'll divide it by 2 square is equal to 4 minus 4 square is equal to 16, and iota square is iota square. 8 minus 16 minus 6 becomes minus 22, as like terms having the same signs added, coefficients are added, so minus 22 iota plus 12, we put the value of iota square, that is minus 1, 4 minus 16, we put the value of iota square, that is minus 1. In the next step, 8 minus 22 iota plus minus minus, that will be minus 12. Whole divided by 4 minus minus plus 60. In the next step, we got 8 minus 12 minus 4 minus 22 iota, whole divided by 4 plus 16 is equal to 20. Applying the inverse action for LCM, we got minus 4 over 20 minus 22 over 20 iota. 4 ones are 4 and 4 fives are, we get what? Minus 1 over 5. 2 11s are and 2 10s are, we get what? Minus 11 over 10 iota. So that is the value of Z in simplified form. So let's begin with the solution of the 4 parts which are required in the question. First of all, we are required to find its conjugate, and that is Z bar is equal to minus 1 over 5. Conjugate is obtained by changing the sign of imaginary coefficient, that is plus 11 over 10 iota. It's very simple. Let's move to the next part in which we are required to find out the sum Z plus Z bar. B part. Z plus Z bar is equal to minus 1 over 5 minus 11 over 10 iota plus minus 1 over 5 plus 11 over 10 iota. We open the bracket, we got minus 1 over 5 minus 11 over 10 iota plus minus minus 1 over 5 plus into plus plus 11 over 10 iota. Like terms having different signs, they are cancelled, and we take the LCM of minus 1 over 5 minus 1 over 5. Denominators are same, we write numerator as same as they are. Minus 2 over 5 we got over here for Z plus Z bar. In part C, we are required to find out the difference of the complex conjugate, and that is Z minus Z bar. We put the values minus 1 over 5 minus 11 over 10 iota minus 1 over 5 plus 11 over 10 iota. We open the brackets, we get minus 1 over 5 minus 11 over 10 iota minus minus plus 1 over 5 minus plus minus 11 over 10 iota. Like terms have different signs are cancelled. 2 imaginary numbers are left, and we take iota as common. Denominator is same, we write numerator as they are, minus 11 iota. We have minus 22 over 10 iota. In simplified form, we get minus 11 over 5 iota. Let's do part D, in which we are required to find out the product of the complex numbers. Z dot Z bar. We put the values minus 1 over 5 minus 11 over 10 iota multiplied minus 1 over 5 plus 11 over 10 iota. Rather than using simple method of multiplication, we apply formula over here, and that formula is A plus B is into A minus B is equal to A square minus B square. Minus, the square of the minus is plus. As we know that negative number having even number power become positive, so that will become positive. 1 square is equal to 1 and 5 square is equal to 25. Minus 11 square is equal to 121 and 10 square is equal to 100 iota square. 1 over 25 minus 121 over 100, put the value of iota square is equal to minus 1, we get what? 1 over 125 minus plus, it becomes 121 over 100. Taking LCM of these two fractions, what we get over here, 25 and 100 the LCM of the 25 and 100 is 100. How we get that common LCM? It's very simple. We recall this 25 over 100. 2 50s are 2 25s are, and now it will be simple. 5 5s are, and 5 5s are, 5 1s are, 5 1s are. 2 2s are 4, 4 5s are 20, 25s are 100. Now take the LCM. 100 divided by 25 in first denominator. 25 4s are 100, and 4 is multiplied to 1. 100 1s are 100, and 121 1s are 4 plus 121 over 100. What we get? Simply we get what? 125 over 100. They can be divided in the same table. 25 5s are and 25 4 equal to 5 over 4. And that is this solution of Z dot Z bar. And that is all for the question number 5 given in. Thank you.